Okay, so the focus of this lesson is distinguishing between linear and exponential. So let's go ahead and fill in our two tables and graphs here. So let's focus on the first one here. So my first function is 2x. So I'm just simply multiplying 2 times whatever x value I'm plugging in. So 2 times 0 is going to be 0. 2 times 1 is 2. 2 times 2 is 4. 2 times 6 is, 2 times 3 is 6. And 2 times 4 is 8. So pretty straightforward there. When I go ahead and graph these, it's going to be 0, 0, 1, 2, and there is my function. So we can see that that forms a straight line. That one's linear. Okay, let's look over here at B. So first let's fill in our table. So this one's a little different. Notice that it's not just 2x, where it's 2 times x, but it's 2 to the x power. So now I'm putting an exponent in here. So if I take 2 to the 0 power, remember from your exponent rules, anything to the 0 power is just 1. 2 to the first power is just going to be 2. 2 to the second power, that's 2 squared, so that's 4. 2 to the third power, that's 2 times 2 times 2, that's 8. And 2 to the fourth power, that's 2 times 2 times 2 times 2, that's 16. So now, when we look at the graph of this one, we have 0, 1, 1, 2, 2, 4, 3, 8, and then 4 way up off the graph. So we can see this bend starting to happen. And when we bend back this way, one key feature of an exponential function is that it never goes down below the axis, so make sure your graph doesn't do that. So now we need to compare, okay? So we're comparing, this one over here is linear. This example over here is exponential, okay? So I think with a graph, it's pretty easy to see that a linear graph is a straight line. An exponential graph kind of starts off growing pretty slowly, okay? Starts off growing pretty slowly, and then all of a sudden it just takes off and skyrockets. That's the difference between the graphs. When we're looking at a function, linear does not have any kind of exponent on it. Okay, linear does not have any kind of exponent on it. And exponential has a variable as the exponent. So you see right here we have a variable as the exponent. That's what makes this exponential. Okay? Looking at a table of data. So you guys should be familiar with a constant rate of change. I'm going plus 2, plus 2, plus 2. That's a linear rate of change. But we can see that if we do pluses over here on B, it would be plus 1, plus 2, plus 4, plus 8. That doesn't really work. So instead of adding by the same number every time, we're multiplying by 2. Multiplying by 2. Multiplying by 2. And that's how we see this is called a constant factor. Okay, so with linear, we have a constant rate of change. We're adding the same number every time. With exponential, we have a constant factor, so we're multiplying by the same number every time.